Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Good morning, T.S. Ricky. Good morning all the participants for the MySET Engineering and Technology Week. So we are very lucky today that we are having our speaker today, T.S. Ricky Liew Chee Leong, that he's the head of engineering of SR Aviation Sendirian Berhad. And for today, Mr. Ricky will be talking on the topic of aligning aviation industry to sustainable development goals and essential for our future. So without delay, I will just briefly introduce our speaker today. Mr. Ricky Liew Chee Leong is currently the head of engineering for SR Aviation, and he's a registered graduate engineer with the Board of Engineers Malaysia. And for your information, Mr. Ricky has a vast experience, more than 32 years in aircraft engineering and maintenance industry, a corporate jet maintenance, repair and overhaul engineering services company. So to know more about Mr. Ricky, probably it's best for him to talk about himself, and just a kind reminder to all that probably it's best to mute yourself and to give Mr. Ricky way for his presentation. Probably will take around 1 hour and 15 minutes, and we will have our Q&A session right after the presentation. Without further ado, I welcome Mr. Ricky Liew Chee Leong to deliver his talk. Thank you, Ricky.
Thank you very much, Professor Engineer Technologies, Dr. Rahim. Okay, before I start, just let me share my screen first. Good morning, Professor Dr. Rahim, and good morning, fellow participants. To this special webinar today. And first of all, I would like to, on behalf of the President of MySET, Malaysian Society for Engineering and Technology, Engineer Professor Megat Johari, I would like to welcome all of you on this special week that MySET has organized for the benefit of the people of the Malaysian. Today, I can see from the participant list, we have people from the academics, we have people from the industry, aviation and non-aviation related. We also have a lot of students, researchers who actually are participating in today's talk. Now, today I'm going to talk about, share some of my view and experience and also opinions to the public and to the participants. And my topic today is actually aligning aviation industry to sustainable development goals. It is an essential, it is an essential for our future. Okay. Before I go on further, I would like to make a disclaimer statement. Now, this presentation is based on general information and experience shared to the targeted audience by the presenter, by me. The following presentation are purely for knowledge purposes, not for you to take it to do any other things. It is just a sharing session, and any particulars or any details of this presentation does not negate the current requirements specification laid down by the regulators and industry. We have to understand aviation industry and a lot of other industry are highly regulated. The authority are the people who actually lay down the specifications, not me. I'm just sharing, I'm getting some of the information that I do the study, I do a little bit of research here, and then I would like to share it to the public, so that everybody will be a better person in terms of sustainability. Now, I also would like to acknowledge all sources of the information Many of it, I actually read it and do a research from the internet, from the books, and also from a lot of the United Nations website. So actually, if basically I'm doing a little bit of homework, and then because everyone is busy, I just do a little bit of homework, and then compile all the knowledge and information, plus my experience, and then my observation and my opinion, my personal opinion, and share it with everyone. Yeah, everyone. You all can take it, you know, if it's good, take it, you know, if it's no good, do further research and make it a better knowledge for you all. Okay, what I'm going to cover today, okay, I'm not sure the participants here, how many of you have delved deeply or think deeply into the sustainable development goals, and especially our aviation industry. Yeah, how does it relate to the current world, to the earth, to Malaysia, you know, to the earth that we are staying now? How is it, how impactful are us, the industry that we are in, impacting the earth, impacting the society? So the topics that I'm going to cover with you today is, I'm going to cover a bit of my introduction, my background, so that you all know where I came from. And I'm going to share with you what are the current world concerns now. There are a lot of things that is happening in the world, but if sustainable become an issue, we don't have to talk about any other things. Yeah. And then the aviation industry impact, yeah, to the sustainable development goals. Yeah. SDG stands for Sustainable Development Goals. I've been working in the aviation industry for the last 32 years. I have never thought that the industry that I'm in has so much of effect, yeah, to the world that we are living in. Yeah. And I'm going to share, you know, a lot of people talk about sustainable fuel. But for today's talk, I have decided not to talk about sustainable fuel. Instead, I would like to share some of the new aircraft, or I won't say it is new, I would say that some of the aircraft propulsion technology alternative. Yeah, we are talking about aircraft propulsion technology alternative to ensure that we can develop this technology further so that we can maintain a sustainable development, sustainable environment, and also be good, you know, doesn't do harm to the earth, yeah, and the place that we stay. Of course, I'm going to end this with a short conclusion before we go into the Q&A session. Yeah. So far, any questions so far? All right. Okay. I have to introduce myself a little bit. The reason is because a lot of these the webinar that I ran, many of times people would like to know the background of the person to ensure that he is the person who is really come from the right industry, Now, my name is Ricky Liew, and I actually started joining the aviation industry back in 1989. 1989, I joined Malaysia Airlines as a trainee artisan. Yeah, I'm not a trainee engineer initially. I'm actually a trainee artisan. And in Malaysia Airlines at that time, the trainee artisan required 3 years of apprenticeship. Yeah, 3 years of apprenticeship. And I'm basically a mechanical, trained in the mechanical trade. Yeah. Then in the 1992, within a very short time after I finished my apprenticeship, I actually very fast, I got my license from the UK, and I actually being recruited back into the trainee aircraft maintenance engineers program in 1992. And from there, I was trained to be a 737 type rated licensed aircraft engineer up to the year of 1995. Now, from 1995, I mean, after I've established as a 737 engineer in 737 production line, in 1995, I actually joined EVA Airways The reason is because I wanted to actually get additional exposure. And at that time, EVA Airways is the only airline that is operating wide bodies. So I joined the EVA Airways as a station engineer for the Subang station, and then later for the KLIA station. And I was there from 1995 to 2002. And after that, in 2002, I joined KLM Royal Dutch Airline, also as a station engineer based in KLIA, and functioning as a certifying engineer until the year 2005, end of 2005. And in 2006, 2006, I joined, I was asked to come into a company, to a company at that time is a private corporate jet company. It has airplane, it has hangar, it has facility, it has all the parts and all those, but there were no people to actually come in to set it up. So I was asked to actually come into this company in Subang and to set up the engineering MRO services. And that is where I came in 2005 until today. We are still sustaining to today. And we are now, we were authorized a corporate jet MRO from Cessna, and also we were once a Part 145 organization from approved under CAM. Now, in terms of dealing in aircraft technology, aircraft engineering and technology, it has always been there for the last 35 years. And there are a lot of observation and a lot of changes, in the past 30 over years. And we, as engineers and technologists, we should actually think deeply about how we gonna make technology and engineering benefit and contribute to the sustainability of the world, especially from the aviation industry. And currently I'm the Vice President, just newly elected last week, and a fellow of MySET, and I am also a chairman of the Malaysian Licensed Aircraft Engineers Interest Group. I know there's a group of engineers, licensed aircraft engineers, who are actually joining, who are attending this, participating in this webinar today. Do join us, and I would like to invite the rest of the members. Do join us into MySET and be part of the community that is very progressively doing this continuous professional development for people like us. Now, sustainable development goals. What is it all about? What is it all about that we actually have a team this year to talk about sustainable development goals? MySET organized Sustainable Development Goals as the theme for the Engineering Technology Week. So yesterday we have 2 talks, on sustainable development. Today we have another talk from the aviation, aviation perspective. Why is it so important? It is very important because it relates to us now and the future. Our grandchildren, our children, our future generations are all affected if there is no sustainable development. So in 1972, it was actually the first United Nations conference on the environment and sustainable development. Way back, 40 years ago, the official first conference was carried out by the United Nations. But the discussion about sustainable development already started since after World War II. During World War II, there was a lot of destruction. There's a lot of destroy. A lot of resources are being used, and subsequently, people, the scientific people, the knowledgeable people, the researchers, the scientists, the social scientists, they start to look into the perspective of sustainable development. So in 1972, it was the first conference under the United Nations. But how much effort has there been done since 1972? Not much, because people still don't take it very seriously. People don't take it very seriously. So much so, in 1987, there is a warning report that came out by one of the researcher, Mr. Brundtland. Okay, he came out with a report called in 1987, Sustainable Development Concept, warning us. This was actually brought up to the United Nations, warning us the negative environmental consequences of the economic growth. We want economic growth, but there are negative consequences if we are not careful. We would like to have globalization, we would like to have industrialization, but if we are not careful, it has a negative impact. And the population continue to grow. Today we have 6-7 billion people nowadays. Now 6-7 billion people means we need to reserve a lot of resources for this, so many people. And the population continue to grow. The population continue to grow. So it is very important that if these negative environmental consequences, we don't take it seriously, wow, I think we will have a problem. Serious problem. Don't talk about going to school. If the weather is so hot that you can't even go up to the outside, how are you going to go to school? How are you going to go to university? Just like COVID-19 now. If we don't solve this sustainable issue, we're going to have problem. So United Nations has spearheaded this seriously, because it is not only affecting one nation, it is affecting the whole global community. Malaysia, Singapore, United States, Europe, Russia, Australia, you just name it. We are all living in the common world. So in 2015, the United Nations came up with the blueprint of the sustainable goals. The purpose of this is actually to address the challenges, the warning that has been given in the report. Now we have to address these challenges, especially from the perspective of environmental degradation, climate change. Climate change is one of the very, very key problems in the world now. And then we have other sustainable issues, poverty. A lot of people still don't have food. A lot of people still live in a very, very poor condition. Address inequality. We want peace, and also we want justice. However, today my focus is related to climate change and the environmental degradation from the perspective of the aviation. So you can see, after the World War II, there are already starting to have concern. Scientists, researchers have already begin to concern about the resources, the climate, the people of this world, the well-being of the world. Okay. Now, what are the objectives? What are the areas that is covered by the United Nations Strategic Development Goals? There are total of 17. There are total of 17 strategic development global goals is to address. Make sure by the year 2030, we are now in the year 2021. There is 9 more years to go, so that we can achieve no poverty, zero hunger, good health and well-being, quality education, equality, clean water and sustainability, and the let me see, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduce inequalities, sustainable cities and communities. And we have this responsible consumption and production. And the 13 Yeah, the one that I'm going to talk about today is about climate action. It's no point talking about climate, just talking about it, just discussing about it. No point, right? That is why SDG United Nations put it as a climate action. You need to do something. All of us, we need to do something. Yeah, this is our focus today, SDG number 13. And the SDG also covers, yeah, life below water, life on land, peace and justice, yeah, and strong institutions, and also partnership for the goal, yeah, for the SDG goals. You have to go through, we can only achieve strategic development goals, sustainable development goals, there's a typo there, sustainable development goals, only through collaboration with everyone, with all the nation. Yeah, so it is very important that by 2030 we are able to address some of these issues. We're going to overcome some of these issues. So total 17 sustainable development goals that United Nations and the world are actually paying attention to. And I hope, yeah, our country, our beloved Malaysia, we are also looking into this seriously. And it requires the effort from all of us, from all the people that is living in Malaysia, from the researcher, from the people in the family, home, in the industry, you know, in the academics, everyone plays a role to SDG. What is the current concern of the world now? The first very pressing issue now. Everybody is concerned. Okay. Can anybody guess or can anyone see my words there? Very pressing issue. It is the CO2 emission and other greenhouse gases that is being emitted now to the atmosphere. CO2 emission and other greenhouse gases that is being emitted from the industry, from the automotive, or from the aviation industry. Yeah, the amount of CO2 that is being emitted to the atmosphere, it is alarming. It is alarming. So much so, the United Nations has warned us. The world now is likely to hit watershed 1.5 degrees rise in the next 5 years. Watershed 1.5 degrees C. What does it mean by watershed? It is a turning point. It is a turning point. Turning point means from the bad to the worst already. It is already bad already. The current weather, climate change in the world now, the global warming that we are experiencing now, the flood that we are experiencing now, the extreme icing, extreme snow, the typhoon that we are experiencing now, in the next 5 years, if this 1.5 degrees C is not being contained, it's going to be worse. It's going to be worse. So a lot of people, I'm not sure about you, a lot of people might think, so what? 1.5 degrees, I can always switch on the aircon, ma. No, people think like that, ma. 1.5 degrees, I could hardly feel it, ma. No. It is a very extreme turning point. Don't talk about 1.5 degrees centigrade, the impact of it. Talk about 1 degree C. Don't talk about 1.5, 1 degree C. What is going to happen if you have 1 degree C? Okay. Now, if you have 1 degree C temperature rise on Earth, yeah, these are the impact, yeah. People will die in greater numbers as they struggle with the increasing heat. When the heat wave come, a lot of people cannot stand it. A lot of people fall sick. A lot of people die. So there will be more people dying because of the increasing heat in the world. Now, 1 degree C, what's going to happen? The ecosystem is going to collapse and extinction will begin. That is why United Nations warned us in the next 5 years, the 1.5 degree rise, it is a watershed point. It is a turning point. It is very, very impactful point if we don't try to control it. So if you can look at the diagrams that I put in on the left-hand side of the slides, you can see from here, this forest that we have in 1992, this is part of the Amazon. If you look at it, it's full of greenery and water, 1982. However, currently you can see it is almost barren. Barren land, barren earth, and you don't even see the water clearly. This is the current situation now, yeah? We are not talking about the next 5 years, 1 degrees rise, or 1.5 degree rise. We are not talking about that. It's already happening. So it's going to be worse, you know? So if you look at the second diagram, this is a lake, yeah? And this is the lake picture taken in 1984. And it's a huge lake with water, fresh water inside. It's a huge lake. If you look at the current right-hand picture now, currently, how much water left in the lake? Only 10%, I believe, remaining in the lake. And you know, human being, our body itself, 70% is made of water. Our brain also 70% made of water. Without water, how are we going to survive? Fresh water, we are talking about fresh water. Due to climate temperature rise. You look at the sea. If you look at the sea diagram that I'm showing now, the corals and the sea habitats in 1984, you can still see corals with fishes and all those. That is in 1984. Many of the sea areas that we are having now in the world has become like the right-hand side picture. The coral reef, the corals has actually died. And do you know one of the most important sea beings to maintain the balance of the whole world ecosystem is corals. And if we don't have corals, we're going to have a problem. We're going to have problems in terms of the balancing of the ecosystem. Okay. And if you can see the right corner picture, you can see the crops are dying, already happening already. It's already happening. So we are facing these issues, yeah? We are facing these issues. So if 1 degree rise, 1 degree centigrade rise, a third of all life on Earth will face extinction. Plant growth will be very slow and stop. What does it mean? We will not have food. We will have very, very limited food. Before it actually grow to produce, to let us harvest, it already stopped growing. So the world food centers will become barren. We don't have food for people. Yeah, and within the next 85 years, 1/3 of the planet will be without fresh water. We will have more intensive wave. We have more frequent wildfires. If you all can see the recent Australian fire, it was so serious and severe. If it's not because of the heavy rain that came, I think more people, more animals, billions of animals has died. So we're going to have more frequent fires, yeah? And we might even come back to remember our Malaysian, we will also have this smoke condition that actually causes a lot of issue. Last time we have flight that is diverted because of the low visibility, because of the smoke. People are getting shore issue, breathing issue, because of the smoke that is created by the fire, and it's all due to the temperature rise of the world. Okay, so longer periods of drought, increase in the number, duration, and intensity of tropical storms. I do not know whether you have encountered, but when I was a station engineer in EVA Airways, and we have this typhoon season, typhoon season in Taipei or in Taiwan, and sometimes even from Philippines. When this typhoon season comes, we have canceled flights, we have diverted flights. Canceled flights has been quite frequent because of the severe typhoon intensity, of the typhoon and the storms. And of course, in the northern side, or the southern side, southern of the earth, we have glaciers that are shrinking, and then the ice has been actually breaking onto the rivers much earlier. And of course, we have plants and animals, ranges have shifted. Okay, all because of just 1 degree centigrade rise, centigrade Celsius. And we got the warning. The next 5 years, 1.5 degrees centigrade is going to rise. And United Nations predicted that by 2025, not far from now, only 4 years only, 14% of the world will rely on desalination water to meet the water needs. We are short of, our fresh water is getting less and less and less. We have to take the water from the sea to desalinate it. You might think, right? Wow, the sea has so much abundance of water, sea water. We still have a good source of water. Please, desalination process, number 1, it is expensive. Number 2, when we process the desalination water, it has a lot of negative impact to the sea, to the living creatures in the sea. So it's not the real sustainable solution. When we extract the amount of water like those that we have in the Saudi Arabia or the Middle East, we think that, wow, there's abundance of water, right? Actually, no. Water there is there, yes, but the process of desalination will be very harmful to the beings in the water, in the sea water. Corals might have issues. So just by 1 degree centigrade rise, you can see the impact of the world. And if you look at it, if we can say, so what, 1 degree C is not much, what? So equally, we can also do a lot of things. We can also be very careful, live in a very sustainable life, a conservative life, so that we can maintain the sustainability of the world. Okay, now if we look at this picture here, this actually shows the global temperature rise and the CO2 rise since 1880. And from the graph here, you can see the amount of CO2 created is on the rise already because of slowly we're coming into the industrialization. Slowly when we are coming to industrialization, we have more plants, we have burning coals, we have burning oil, fuel. Because of industrialization, all this actually created the CO2 and also the rise in the temperature. So you can see from 1880 to the 2016, our temperature is already rise up to 1 degree already. And you can, so if you study and understand this graph, right, the current condition that we see in the world now, lack of water, extinction of animals, we are losing all the greenery and all those. You can see it is not abnormal because the temperature has been rising and there was no control over it. There was no control over it. Are we going to continue to move like this forward, or are we going to address these issues here? As engineers, as technologists, as human beings, as researchers, you and me can do something about it, yeah? All right, let me just go to the next slide. Oops. Oh, yeah. Okay, now I want to show you something, yeah? These are the few questions that I think we should look back into our current environment, the place that we are working in, the aviation industry. Do you know that in 2018, the aviation industry produces 1.04 billion tons of CO2? Billion tons of CO2. Can you imagine how much is it? Just in 2018, the aviation itself produces 2.5% of the CO2 emissions. Of course, we can say now COVID-19, no flight and all those, very minimum flights and all those, but that is not the solution. That is not the solution. We have to look into this issue in the more technical details, which I'm going to share afterwards. Do you know that the passenger CO2 emission from a wide body aircraft? Yeah, for us, yeah, we have wide body aircraft, we have narrow body airplane. Let's give example of the narrow body airplane. I mean, the wide body airplane, the 777, yeah, one of the most popular jets in the world. In 2019, yeah, just this 777 alone, the CO2 that is actually being produced by this whole fleet of 777, it is 77 million metric tons. It's a lot. We have not talked about 74. We have not talked about Airbus 320. We have not talked about Airbus 330. We have not talked about A350. There's so much of CO2 that has been produced. And just for comparison's sake, a jumbo jet can burn over 200,000 liters of fuel in one trip. Just one trip itself. The emission from the engines, it is about 500 tons of CO2. A lot or not? Just one trip, 500 tons of carbon dioxide. Heavy, right? Real heavy. Okay, now CO2, the more CO2 we produce, the more CO2 in the atmosphere, the more heat from the earth is going to be trapped. It's going to be trapped. And of course, CO2, whatever the gas turbine engine combustion that we have, apart from producing CO2, it has also other greenhouse gas like methane, nitrous oxide, and a lot of other gas. All these are greenhouse gases. So from here, we would know we have to do something in the aviation industry. So the effects of climate change is very, very severe. Yeah. We have increased number of forest fire. We have prolonged drought. We have lack of fresh water. We have increased number of fierce typhoons and flooding. Places they are not supposed to flood, it becomes flood. It has flood. People are places or countries, areas that are not supposed to have drought, it has drought. Areas that's not supposed to have snow, it has snow. All these are all the effects of the climate change. And of course, the worst, yeah, this is affecting our crops. Yeah, we have crops that die because it's hot, and because it's hot, we have no water. The land starts to crack, and people become hungry because we have no food to eat. And when people have no food to eat, it is easily become chaotic. Easily. And extreme climate faced by the population. If you look at here, look at this picture here. What can you grow in this kind of climate? Not even fish can grow. This kind of climate is extreme. It's iced up everywhere. And people living in this city, they have to depend, they have to rely on food sources being brought in by somewhere else. And if you think about it, if that area is also affected by the climate change, got crop but no harvest, also another issue. So we are living in a very, very serious environment now. Apart from that, apart from aviation, we are also having industry that is actually producing a CO2 because of using high fossil fuel. We also face the decreasing oil resources. Now think of our future and generations to come. Think about them. Think about them, our children, our grandchildren. What's going to happen to them if we don't start by looking and addressing these issues? We have to understand global warming will escalate, the climate change. Global warming will escalate the climate change. Because of the climate change, and negatively is going to cause economics, political, and social chaos. You talk about going to work, how to go to work when there's a social chaos, isn't it? You say you want to do this, you want to do that, but there's a social chaos, there's an economic chaos, and there's a political chaos. You cannot do all this. You cannot live a normal, living, peaceful life. So think of our future generations. So when there's a food production shortage, when there's a drop due to drought, flood, and extreme heat, food prices will soar, will rise, and many food will be scarce. Social unrest will rise. You will see people fighting, robbing, killing, murdering. Some of the examples has already been seen during some of the effects of the climate in areas like in America, in Katrina, during the Katrina typhoon. Do you all remember? People are breaking into the shop houses. People are killing for food. People are damaging the properties. All these things in US. This is the picture of the typhoon Katrina. And what will happen if the storms continue to grow violent? Okay, we have not even talked about damage to homes, damage to businesses yet, damage to infrastructure. We have not talked about it. So if we sit down and start thinking about it quietly and reflect on ourselves, reflect on the environment that we are in now, you realize that no, this cannot go on. This cannot go on. Okay, so how aviation industry can align with sustainable development goals? How? Okay, so during the United Nations Sustainable Development Goals, much earlier this issue has been addressed to the aviation industry. Okay, now aviation industry has been working very hard. I'm talking about right from the designers of the aircraft, designers of the engines, designers of the systems on the airplane. They have been working very hard to ensure that we can design or develop technologies that can help sustainability, reduce the CO2 emission. Even though we have made progress, but we are still very, very far away. A lot of investment are being put inside the research and development to find the best engines, the best systems, reduce emission, best propulsion system. A lot of investment has been put into it. However, we are still very far from the goals that we want to reach. We are still far away, which means we still have a lot of work to do. We still have a lot of work to do. Doesn't matter whether you are licensed aircraft engineers, design engineers, researchers, whether you are aviation staff in the airport or in the office, in the operations, all this, we have a role to play. So we have to understand one point here. Not only aviation impact the climate change, not only aviation will impact the climate because of the CO2 emission that is being emitted from the aircraft engines, but remember, once the climate change, it also impact the aviation industry. Like I mentioned just now, when I was the station engineer for EVA Airways, when the strong typhoon comes, our flights have to be cancelled. Heavy snow in US airports, extreme snow, airport has to be closed. Operation stop or flight diverted, flight cancelled. So it is two sides of a coin. Aviation produces CO2 that impact the climate change. Once the climate change, our operations will also be impacted. We also have to change. So this kind of consequences is actually continuous. We have to put a stop to it as much as we can. We have to put a stop to it. This is a graph, yeah? This is a graph that shows the CO2 emissions, how much CO2 emissions based on the general transport categories. Of course, the electrical train like Eurostar. Anybody knows the where Eurostar is? Anyone knows? Have any one of you has rode on the Eurostar before? I had once, yeah, when I was actually doing my training in Belgium and German. I actually went and took the Eurostar went to London. It is actually an electromagnetic train. You can see electromagnetic train. You see the CO2 produced is so little. Yeah, a coach can produce 27 grams per passenger per kilometer travel. A domestic rail, yeah, that doesn't use high amount of electricity. It produces 41 grams. And if you go up the list, you can see airplane, aircraft, yeah, and also the cars, yeah, produces high amount of CO2 emission per passenger per kilometer travel. And we are talking about these using fossil fuel, yeah. These airplanes, these cars, these buses, these are the using fossil fuel as the combustion source, as the energy source. High level of CO2 emissions. Now, this is the diagram where we can see a comparison of technology since 1960. A 1960 Boeing 707 takeoff on the left-hand side. Do you see the amount of smoke, unburned hydrocarbon that is coming out on the engines of the 707? Black smoke, unburned hydrocarbons. And that was the technology at that time that we have. And you know that 707 is one of the most popular jets in the world at that era. So you can see how much CO2, how much smoke, how much pollutants has been produced to the environment by these engines. Of course, the researchers, the engine manufacturers, the designers has continued to develop new technology. So today, compared to 1960, we have 50% less CO2 produced by the engines. But 50% is still a lot. It's not good enough. And it also, the engine nowadays produces 90% less smoke and unburned hydrocarbon, and 40% less nitrogen oxide. Guess what? Not enough. Technology, even though we have working very hard, we have been working very hard, designers, technologists, engineers has been working very, very hard to come up with the best minimal engines, fossil fuel engines, still not good enough. Of course, recently we can hear that people are using biofuel. Biofuel, that means we are not using fossil fuel, we are using biofuel produced from algae, and then we emit very, very much, even lesser CO2 to the environment. But even that, the production on the algae producing the biofuel, it is still very, very low compared to fossil fuel usage. And the production of biofuel, it is not easy, yeah? It is not simple, and it's still very costly currently. So we have moved on from 1960 to 2019. We have developed quite well in terms of technology, but it is still not good enough. So if you look at it, between 2020 and 2040, we're going to have about 6 to 8 billion tons of, if we continue to use existing technology now, we are producing another 6 to 8 billion tons of CO2. So if you look at this graph here, if you look at this red graph here that I'm pointing now, this is the amount of CO2 that's going to produce if we use existing technology. If we use existing technology, which means 2010 technology, 2010 operational efficiency. So the graph is on the rise. That is why I say no good, not good enough. All right. Now, if we develop improved technology, the current improvement now, we can bring the graph to the lower, to the blue zone, here that you can see. Yes, we are able to drop down the CO2. But if you look at the target, yeah, emission target, we want to cap the emission target to the year 2020 levels. You will see, if you see the line on the graph here, we still have a very, very big gap. Very, very big gap. So the question is, can we continue to use fossil fuel gas turbine engine? Can we continue to develop? How far? How much more can you develop? How much more? I think there is a certain restriction, right? And you cannot do it fast because we only have 5 years only. So it is very challenging. The closest and the fastest, yeah, system that we have. That's why today I did not choose to talk about fuel. I talk about propulsion system. I want to talk about propulsion system. Think a propulsion system beyond fuel, beyond biofuel, beyond fossil fuel. Think about it. So the closest that I can see, which people, the engineers and researchers has been working on, and in fact has produced some of the prototypes, is the closest one is electrification of the aircraft propulsion system. Electrification of the aircraft propulsion system. That means we do not want to use fuel to burn and produce the thrust to become the propulsion, to use as a source of propulsion for the airplane. We want to use electrification. Electrification. Because by electrification, we solve two problems. Number one, we improve air quality, reduce CO2. Reduce CO2 means reduce the impact of climate change. The other thing that we actually talk about is actually reduce noise pollution. Because full electrification of engines, aircraft propulsion system, you can eliminate almost the complete noise propulsion system, noise pollution. Of course, that is another topic. Today, our focus is actually on the emission, yeah, on the emission. Now, like I said, a lot of engineers, a lot of technologists, and a lot of technicians has been working very, very hard since the 70s to come up with the electrical propulsion system. This is the current state that we have now in the world. There are a total of 87 models. We have Czechoslovakia, we have USA, Italy, Germany, Israel, you know, Switzerland, Canada, Japan, China, Slovenia, Brazil. What about Malaysia? Have we thought about it? What about Malaysia? What are we doing? What are the problems that we are facing? Okay, so I think engineers, graduates, technologists, technicians today, we should think about it. Of course, I understand there's a lot of factors, social economic factors that is involved in producing airplanes, but we really have to seriously look into this. The government has to support, otherwise we will be left very, very much behind. So engineers, come on. Yeah, you are the future. We rely on you. Okay, so what are the class of electrical propulsion that has been developed so far? Okay, a lot of it is actually motorized propeller. That means we have an electric motor at the front to actually mount a propeller, and we use the electric motor to turn the propeller, and in return it gives a propulsion force to the airplane. 60% of it are being used. Motor glider, we have used a lot of electric motor propulsion system on motor glider. We have ducted fan. Yeah, afterwards I'm going to show you a ducted fan using electric only to produce thrust, and it's already been developed. The prototype is already there. Rotorcraft using electrical propulsion system, airship, personal air vehicle, light spot airplane, and of course UAVs. We have a lot of majority of the UAVs uses electrical power to actually, as they are used as a propulsion system. And what are the power source that we have been using? The number one, the highest number one is the battery technology. Like the Alice electric airplane that you see here, it uses a battery technology. The Cessna 172E here is uses solar panel. 23% of the aircraft nowadays are using solar panel. And we have a hybrid 6%. Hybrid means a combination of fossil fuel and electrical propulsion system. Yeah, or even the hydrogen. Okay, we have a cable power source. We are using cable 2%, and we are using fuel cells. Fuel cells are being used to generate electricity to drive the motor as a propulsion force. And very stressed that actually we are still facing a lot of problems with the battery technology. We are still facing a lot of issues, but problems means that we have to do more work, do more research, do better design, do better study. Yeah, so these are the current electrical propulsion airplanes that we have. 84 models in the world. Okay, now I'm going to share with you here. This is what I said just now. In the Airbus, yeah, Airbus basically has took the lead, yeah, and actually announced it to the world that they actually work on the zero emission airplanes. They have actually targeted, and actually they have proven us. They actually in 2015, 5 years ago, they actually developed a prototype Airbus E-fan. Yeah, this picture that you can see here, this aircraft is purely electric. Yeah, using the battery power, and then to actually turn the ducted fan, electric fan, to actually produce thrust. And this airplane crossed the English Channel successfully in 2015. That means we have already have the good, very, very good start. You know, electrification of aircraft. Very good start. And on the left here, you can see if you Google the Airbus website, this is now what you can see. Yeah, the conceptual stage of the design of the plane, Airbus E-fan X extra. Yeah, extended extra beyond that first E-fan. So you're talking about electrical power. Yeah, electrical power, 3000 volt DC electrical distribution system, data transmission system, electrically powered, energy storage, high power battery pack. Yeah, we do not have the best battery pack now, but they are under research. There are already battery packs, but they want more. They needed more. Yeah, and at least Airbus say in the next 10 years, one of the 4 jet engines is replaced by an electric motor, and it has an electrical generator power system to produce the electricity required to actually work, to operate the engines, to operate the propulsion system. And there are other designs that you can see here. For example, the Liew VTOL aircraft. It is already flying. Yeah, it doesn't use fuel. Yeah, it uses electrical power. Of course, the capacity is not many people yet, 2 people, 3 people. The payload is still very less. It shows that we still need to extend our research even further. So those graduates, those researchers, those engineers that we have participating in this webinar today, please, yeah, look into this area. Now, this is a 4 million electrical commuter jet, 4 million, US 4 million. And it can carry about 9 passengers, 9 plus 2. Just want to check with you, do you all know how much is a corporate jet, business jet cost? Carrying the same amount of passenger, but burning fossil fuel. Anybody has any idea how much a Cessna, let's say a Cessna Citation jet, yeah, carrying 9 person plus 2 crew, a business jet that can fly for 5-6 hours. How much does it cost? Currently, it is costing about 16 to 17 US million. 16 to 17 US million, a Citation fossil fuel burn aircraft, fossil fuel engine airplane. And this airplane, USD 4 million, Alice electric commuter jet, US 4 million. Comparatively, I felt that it is quite reasonable, Yeah. Anyway, the prototype has been developed. It flew to Paris Air Show, but recently, because of the battery technology, remember I said we have battery technology problem. It burned. There was a fire in the battery, and it burned the prototype. It actually damaged the prototype. So they are developing again. Yeah. So, but anyway, the target of entry into service in the year 2023. Then there's a question here: will electrification of airplane be a disruption to the aviation industry? I believe so. Yeah, I believe so. If we have the battery technology, electrical technology that is even better and better, it's gonna be part of the disruption of the aviation industry. This is the specification of the Alice Aviation, just to share with you that electrification of aviation industry, electrification of aircraft propulsion system. It is possible, and it's already been done. And this airplane, if you look at it, is a 9 passengers airplane plus 2 crew, have a payload of 1,134. Length is about 13.2 meters. 4.2 height is about 4.2 meters, and a wingspan of 16.12 meter. 3 motor powered propulsor. We call it propulsor. And if you look at here, look at the weight. The battery weight itself is already 3.6 tons. So a huge amount of the weight of the airplane, it comes from the battery. The battery technology currently is still not good enough because we still have battery that is very, very heavy. If we can reduce the battery weight by 1/3, probably 1,200, then I think this is another big achievement. So you can see the Alice electric aircraft is already flying. And it's there. It is there. We can do it. Okay. Now this is a slide where I share with you what are the current problems with our battery. I focus a lot on the battery is because this is the low-hanging fruit. This is the low-hanging fruit in terms of reducing carbon emission. Electrical technology is there. There's a lot of papers, a lot of research that has been done on it. All you have to do is study this research and then come up with new ideas, to achieve better electrification of aircraft. Yeah. So the challenges of the electric aircraft now, these are the challenges that we have. We have limited endurance. That means it couldn't fly very far and very long. A 747 or 777 from here to London, probably direct flight is probably around non-stop, probably around 11 hours. But if you want to fly with this electrical airplane, it will have a lot of challenges. It cannot go there in 11 hours. It probably have to have several stops, and probably by the time it reach there, probably it will be 20 hours or 24 hours. So this is the challenges that we have because we are limited by the battery technology that we have or the electrical power technology that we have. So limited endurance. The other problem with the challenges with the power battery is power to weight ratio of the batteries. Like I mentioned just now, the airplane itself, electrical airplane, Alice aircraft just now, 3,006. 3,006 is actually the weight of the battery. It's so heavy. Can we reduce it to 1/3 with the same power capacity? If we can, then it is a successful. It is a disruptive technology. It's advancement of technology. The energy density of the battery is still very low compared to fossil fuel. You see, if you can see here, lithium-ion batteries only produces 160 watt-hour per kilogram, whereas a Jet A1 produces 12,500 watt-hour per kilogram of fuel. That is why we say the battery energy density is still very low. Can we produce a battery with high energy density? Maybe we can increase it to 500 watt-hour or 1,000 or 2,000 watt-hour per kilogram of battery. Can we do it? It's up to us. It's up to us. The new battery technology, because there is a lot of problem of heat generation. Battery came on fire, and you can see some of the cases, even on the existing airplane that we are flying. We know that the lithium-ion battery has caused problem on the 787 and probably some other Boeing airplanes as well, because of the thermal system. The heat generated is actually, we need to find way to dissipate the heat with a more improved technology. Otherwise, the battery is going to be overheat. And also, because of the overheating motors, batteries, and cabling system, we need to come up with thermal conductive and insulation system. We need to come up with a better one. So if you can see on the right-hand side of my slide here, this is the result of a burn battery. Lithium-ion battery, burn one, you can see. And it can burn down the whole airplane. Just like the Alice airplane. The prototype that has been burned down, once the battery fire starts, we have a problem. Very hard to extinguish it, and the battery is so packed and hidden underneath places. And aviation industry certification, if we want to go for certification of airplane with more 19 passengers or more, we will have to get the authority to get it approved. So aviation authority certifications, we also need to work on it. Currently, there is not much of precedence to go into bigger jets and bigger airplanes. So these are the challenges that we are facing now in terms of electrification of airplane, which also means more opportunity for researchers and engineers. Yeah. Now, this is something that I mentioned just now. Airbus has came out with the in the last year, 21st September, the Airbus reviewed 3 concepts of world first zero emission airplane. This airplane looks nice, right? Airbus 0E, zero emission. It is a conceptual now. They uses the blended wing body configuration. Yeah, blended wing body for configuration. 2 hybrid hydrogen turbofan engines. Hydrogen turbofan engines to produce thrust, and it will have liquid hydrogen storage tanks underneath the wings. The target of this one is zero emission, and they enter in service by 2035. A little bit too late, right? For the 1 degree temperature rise. Do you all think so? Wouldn't it be good if this has come out about 20 years ago? Yep, just my thought, but we still have to work on the problems. Now, this is something else. Just now I've discussed about the current low-hanging fruits, things that being vastly and highly worked upon. Now, there are also other propulsion systems, yeah, that has been, study has been done since 1960s. And you can see in some of the movies, for example, if you see the Star Trek, yeah, the Star Trek ship Enterprise, you can see the propulsion system emitting a light blue emitting. This is actually an ion propulsion system. We have not been able to move very, very far on the ion propulsion system. This technology is there, has been working on since 1960s. And these ions, it does not use fuel. It does not use fossil fuel. It uses propellants such as xenon and krypton, and they use electric field to accelerate the ions. That is why they call the ion propulsion system. We have not developed this yet successfully and apply it into the aircraft industry. Currently, it is being used on the satellite systems, on the space vehicle. Yeah, space vehicle, not the space shuttle. Yeah, space shuttle still uses fossil fuel. Yeah, hydrogen, liquid hydrogen, and oxygen. But this one uses xenon and krypton, and we need to develop and further research, do further research on this ion propulsion systems. There are quite a few of it that is still underdeveloped. Yep, engineers, technologies, please go into this. Okay, the other one that we talk about is the plasma jet engine. Also has been doing research since 1960. 1960 to now is already 50 years ago, 51 years old, 51 years ago. We have not achieved very much, yeah, practical utilization in our daily life, not much of it. And what is a plasma jet engines? Plasma jet engines uses electricity to generate electromagnetic field. And this electromagnetic field compresses and excites gases. It just uses air, our ambient atmospheric air or argon, into a plasma, a hot, dense ionized state that accelerate. And by this acceleration, we're going to use hopefully it produce a reaction. Remember Newton's third law? Every action, there's an opposite reaction. We want to develop this even stronger. There is this propulsion engines, there is plasma engines, but the application in the aerospace industry is still not there yet. Still not there yet, yeah? Okay, this is the 2018 in China. There is actually a breakthrough, yeah, in terms of plasma rockets. That means there is a big breakthrough in terms of developing plasma propulsion system in 2018. I don't have the details, but I know I've watched their talk, their description and explanation, and actually it was a it is a leap from the previous technology to now 2018. There seems to be have a breakthrough with higher propulsion force, because ionic thrusters, plasma thrusters, generally they produce very small amount of thrust, but this breakthrough in 2018 has actually able to produce much higher thrust. Yeah, hope it can use into the aviation aircraft applications. Yeah. Now this is also another one, a photonic propulsion system. Now this photonic propulsion system is more for the rocket, yeah, where the laser beam is focused on the airplane or the spacecraft and to point at it so that it produce a propulsion force and push the rocket. Of course, this is just to share for the knowledge. We cannot apply this in the aircraft industry because airplanes climb up and down, whereas a rocket is pretty straight forward, yeah, compared to the aircraft relatively. But one thing we want to know, we need to know is that the momentum from the photons, yeah, photons, electron, protons, photons. If we are able to tap or harness the energy from the photons, we are able to use photons to generate thrust. Where are we now? We are still very far away, yeah, very far away. Now, this one, yeah, this one is nothing new, because this has been there since the 1980s. This is a triangular flying machine. They call it TR-3B. Okay, TR-3B uses electrostatic rotating propulsion system. It is this data now is accessible by the public, but it is already patented. What it's trying to say here is that this airplane can fly without using any fossil fuel. What they do is they use electrostatic energy and magnetic energy to actually create a propulsion on the flying machine. Can we use that on our airplane? It's there. Since 1980s, they already started developing, and now it is in the public domain where you and me can go and download the patent and study about it and come up with a new technology for the airplane. Yeah, so this is something that I think we need to expand our mind, yeah, to consider various type of option of propulsion technology that we can develop, and hopefully together we hope to solve the sustainability issue, yeah, of using fossil fuel propulsion system. So many options are there. And this is my conclusion of the last slide. Carbon emission put all of us in the same boat, yeah. Doesn't matter you are in Malaysia, US, or Europe, or wherever. Carbon emission pull all of us in the same boat. Like the straw drip of water filling the sink and causing it to overflow. Our atmosphere is already full of carbon. Already full, ready, too much ready. Because we are already suffering from the effects of climate change, the next big thing to do is not to slow it, but how to stop it. We really need to stop it. The atmosphere and the oceans are already full of CO2. We are talking about storing, capturing the CO2 and then storing it underneath the ocean, underneath the ground. We have to, the current a few nations now is already having the technology to capture all these carbons and store it into the ground, store it under the sea, under the ocean. Why? Too much. Too much. So we cannot take it anymore. The earth cannot take it anymore. If they could, we would not be experiencing the rapid climate change we experience daily. So global warming is a global warning. Global warming, yeah, is a global warning. Climate action, we need to take action now. Yeah. Okay. So that is that actually concludes my presentation. I hope, yeah, that we will work sustainably while practicing in our profession. If you are a researcher, do your part. Engineers, technologists practicing in the field, do your part. Yeah. And thank you so much for your attention. And before I end, I just hope that if every one of you have any questions or not. And I would like to pass the mic, hand the floor back to our moderator, Professor Engineer Technologist, Dr. Abdul Rahim. Over to you, sir. Thank you. Thank you guys for your attention.
Thank you very much, TS Ricky, for the very exciting talk. I believe the participants, especially in the Zoom session, as well as those who are a bit unfortunate that cannot enter our session in Zoom, they are viewing the session through MySET Facebook Live. And there are a lot of questions being thrown. There are a lot of challenges out there, but probably some of it can also be contributed through everybody, meaning that everyone should also try their very best to overcome and also try to create something that can reduce the carbon emission probably, or create new technology. And just for your information, Ricky, before I open up the session to everyone else, the participants are in this session. We have clocked in 100, and there are, I think, more than 25 people viewing it through Facebook Live. That one is about half an hour ago. I believe there are more and more people coming in. And we also have participants all the way from, I believe there are from Abu Dhabi, there are also from Mauritius, from Iraq, Baghdad, and some other places all over the world. And it is not limited to Malaysian participants. So there are a lot of things being discussed in the chat box. Probably some of you, especially those who are in the session, you would like to ask directly to Ricky. Maybe Ricky can answer, or anyone else also can also chip in. So I open up the session.
Thank you, Prof. I'm very impressed by the number of participants, and it is not only now, it is international, and that actually proves the same point, the weather and the climate change that we are combating now. Everybody is facing it. Doesn't matter whether you are in Malaysia or overseas. I'm very sure we can do our part together. We overcome this this problem. And if you guys have any questions, we can actually discuss it here. I'm not an expert on sustainable development goals, and what happened is that I've never actually discussed about this, except until I was given the duty to do a presentation for the benefit of the public from the perspective of sustainable development. And let me see, is there any question?
In the chat box, probably I can just read it aloud for you, Ricky. From Dr. Hanafi Azami from UIAM or IUM. He's now working on alternative fuels or biofuels and hydrogen in aero gas turbines. Very good. His question is that, do you have any information on the battery cycle for the overall carbon footprints, starting from the production as well as disposal? I believe this is the main challenge as well. Maybe you want to respond to it, Ricky?
Okay. Thank you for the questions. Actually, what happened is that I feel that the information and the knowledge that we are able to download from the current battery technology that we have now, we do not see very much details about the battery cycles and the life of the battery. There are some write-out, but it is not much. So therefore, I am not able to provide you with this this answer. But I will encourage you, I will encourage you to actually look at the, especially the website of e-aviation, the Alice airplane. They were willing to actually share a lot of the information, but still don't have much technical details. But if you do a research of it, I think you are able to find the answers. I definitely do not have the exact answers on these cycles of these the batteries that we are having in the e-aviation or electrical aircraft. Thank you, and my apologies for that, Dr. Hanafi. Yeah, Dr. Hanafi. But please, you are working on a very good project, alternative fuel, biofuel, and hydrogen. And I hope, we can come up with good results. Good results, so that it can actually help the industry and help the people in the world. Thank you so much, DS Dr. Hanafi. Yeah.
Okay, another one question from Mr. Chin Kian Xiong. He mentioned here, Malaysia being an oil-producing country, how do you reconcile the oil and gas industry with carbon emissions?
Okay, I think the oil and gas industry is facing one of the most difficult challenge, actually, from the pressing of the United Nations initiative. The issue now is actually, is our Malaysian regulatory body, how are we responding it? It's actually very difficult to actually balance it up in terms of economic sense, economic benefits, and also the pollution that is being affected by our oil and gas. So regulatory wise, I think on one hand, we have to enforce it. On the other hand, we also have to be very careful not to what they call it, cripple the economic benefits of it for the moment. And at the same time, we need to accelerate the utilization of alternative source of energy. We are talking, I think, wind energy, we don't have much here. Solar energy, I know the Malaysia is slowly working on this one. But in terms of electrification, or even on our airplane, on our aircraft, I mean, not aircraft, our automotive, it is still very, very lacking, very, very lacking. So the balance is very hard to balance. So I will leave it to the regulatory body and the economic and the social politicians, to actually work on it. But keep in mind, the problem on the weather on top of our head is affecting whether it is a politician or non-politician. So thank you. I hope that answer TS Chin's questions. Not an easy question to ask. To answer.
Okay, thank you, Ricky. There's another one from Mr. Lim Chi Ho from Malaysia Airlines. The question is, Airbus has been developing their zero emission project aggressively, which is the fuel cell hydrogen propulsion. So it is a clean energy alternative. What do you think about the prospect of it to slowly replacing fossil fuel propulsion, as Airbus already commit into this project?
Okay, my understanding of aircraft manufacturer, including Boeing and Airbus and other manufacturers, they already understood the sustainable issue, the climate issue, and also the negative impact of the fossil fuel production system, propulsion systems. And they are putting a lot of resources into this zero emission, because why? The future is actually zero emission. Whether they like it, whether they don't like it, the future is actually zero emission airplane. It is a matter of time. It is a matter of time. When is it going to be effective? The faster the technology, the research is successful, the faster they're gonna implement it onto the airplane in their production. They have to, because we are actually, the Earth is actually, let's put it in another words, the Earth is actually dying. When the Earth is dying, people is also dying. So basically, strong technological engineering-based company like Airbus and Boeing and all those, they have no choice but to go into it. Yeah, very good prospect. That is my opinion. A lot of expenses need to require a lot of resources need to be invested, but that is the only way forward to me. Yeah, thank you so much.
Okay, thank you, Ricky, for the answer. I just probably this is the last question from Engineer Sabri Zain himself. I think he's in our session now, but I can just read it out. Dear TS Ricky, which government agency is the most active to spearhead our improvement actions related to this issue? The issue on aviation, sustainable, and so on. Yeah.
Okay, I would say in terms of sustainable climate change and all those, currently I believe, yeah, MOSTI is the one that is actually involved. If you know earlier, the earlier government before to this government, the ministry has changed its name and it has an environmental word inside there. So I believe the agency, the Malaysian government agency, the one is actively or should be actively promoting this SDG. To me, spearhead is still by MOSTI. I've not seen any other agency yet that is spearheading or given the full responsibility looking into the SDG. And I think we need to do it. We really need to do this desperately for our Malaysian. Yeah. Thank you so much for the question.
Okay, thank you. There's one response from Noor Aina saying that the government agency is Kementerian Tenaga, Teknologi Hijau dan Air. Maybe one of the agency that the ministry that is responsible on the SDG. But again, there are a lot of interesting issues that we can discuss further and further. But time is not on our side. I believe a lot of other people would like to ask questions and give opinion, but probably we can continue later on in our future engagement. But before I forget, there's a request from the secretariat that we would like to take group photos. Probably it's best for everyone to turn on their camera and to show their beautiful and handsome faces during this holiday break. That's the main reason that we have a full house today. Cuti pun kita bekerja. Okay. All right. So is it ready? Maybe the secretariat, Shakir or Putri or Zura can take the photos. And is it ready? Yep, I think we have to take, there are 4 pages, ada 100 participants, so we can take time. Okay, one by one. Okay.
Ready. Okay. 1, 2, 3. Okay, sekali lagi. Okay, ready. 1, 2, 3. Okay, thank you.
Okay, terima kasih banyak. Thank you very much for TS Ricky, and I believe all of you, if you are not a member of MySET yet, probably this is about time to join us. There are a lot of interesting activities, not just on aviation or aerospace. We are having all the engineering fraternity, okay, from agriculture to space, aerospace. So join us in the future events. Just want to highlight that there will be another webinar that will be conducted in this Engineering and Technology Week, which is called it is organized by Malaysian Affordable Housing Interest Group under MySET. And it is going to be on the 9th of June 2021, starting at 10 a.m. For more information, you can view our website, MySET website, for further details. And do not forget to provide your names and email for those who are interested to get the certificate for this particular session. For those who are in the Facebook session, you can always put your comment in the Facebook comment. With that, thank you very much, TS Ricky, and those who are here with us today. And stay safe and have a good day. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bye-bye for now.
Bye. Bye.
Thank you. Thank you, TS Ricky.
Thank you very much, everyone.
Thank you.
Thank you very much. Thank you.
Very good session. Thank you.
Thank you.